In this video, we'll try to address definitions of what is type 1 error, what is type 2 error, what is power, and what are the things that impact power. So first, let's start with something that you're familiar with. Um, this is where we had the four scenarios. And if you remember, we had talked about the disease and the healthy, and they're being tested, and the test can either come positive or negative. And out of that, if somebody has the disease and they test positive, then these are the true positive. If someone has the disease and they test negative, then these are the false negative. And if someone is healthy and they test positive, then this is the false um, positive. And if someone is healthy and they test negative, then these are the true um, negative. Okay, now before I continue, I would like to do a little bit of rearrangement. So what I'm going to do is I'm just going to flip this to this side, and I'm going to flip these two as well. Um, just because I like to see things a bit done differently when I'm talking about the errors that I will address in a minute. So first, let me flip these two and flip these two. So now these are actually they become the healthy, these become the disease, and this is the negative and this is the positive. So if you're healthy and you're testing negative, then obviously this is the true negative. Let me correct them. Okay, so if you're healthy and you're testing negative, that's true negative. If you're healthy and you tested positive, then that's a false positive. If you're diseased and you're testing negative, then this is a false negative. And if you're diseased and you're testing positive, this is a true positive. Okay, now, if you think about it, what you have on top here and here, this is the reality of the real state of the patient. And what you have here is what the test is saying. So these four scenarios were made based on the setup that we have reality and we have test. Okay, so similarly, we're going to adapt the same rationale to the testing hypothesis. Okay, so we're going to create four scenarios, and reality is going to be right here. So this is reality. And right there is what the test is saying to us. Okay, so what could be the reality? There are two possibilities. And remember, in testing hypothesis, we're testing a hypothesis that basically the null hypothesis. So the null hypothesis is either true or the null hypothesis is false. Okay, so for the healthy, it means that there is nothing going on, the patient is healthy. This coincides with the hypothesis of the null being true. Okay, there's nothing going on. The null hypothesis is true. Okay, excuse me. So that's the healthy. Amma, if the patient is diseased, meaning that there is something that is happening, there is a departure from the state of nature, then this is where the null hypothesis is actually false. And remember, these two scenarios are the reality, which not most of the time, every time you're doing a research question, you don't know what the reality is. But hypothetically, these two conditions of reality exist. مثل ما when you're testing for patients to know if they're healthy or diseased, you don't know their real status, otherwise you would not test them. Same idea is applied for testing hypothesis, either the reality that the null is true or the reality that the null is false. Okay, and what we're going to do is we're going to look for each reality what happens. Well, two things can happen. Either the test, like here, is negative. شو معناتها the test is negative, meaning that you're declaring the p-value is not statistically significant. So you are failing to reject. Okay? Failing to reject. This happens when your p-value is greater than or equal to alpha. Or the test is positive, like here, meaning that you're actually rejecting the null hypothesis, and this happens when your p-value is less than alpha. Okay? So same idea when we had healthy and diseased, and you test them, and their test is either negative or positive. And same thing, either the reality is that the null is true or the null is false, and then we're using a test, whether it's a z-test or the t or the pair t-test or the independent t-test or any kind of test. And two things can happen: either you fail to reject or we reject. So let's see the four possible scenarios. If the null is true, and notice I said if the null is true, so it's a condition. If the null is true and you fail to reject the null, then you made a correct decision. This is correct. Okay? That's a good thing. On the other hand, if the null is true, however, you rejected the null, then you made a mistake. Okay? Similarly here, that was a true negative, and this is a false positive. You're declaring the results to be positive, though in reality they're not. Exact same thing here. You're declaring that the null, you're rejecting the null, though the null is true. So here you have made a mistake, and this is called type 1 error. And the type 1 error has a value equal to alpha. Okay? So most of the time alpha is 5%, right? Okay. Now this is a conditional probability and this is a conditional probability, and they should add up to 100%. Okay, which means that the probability of this to occur is 1 minus alpha. Okay, and we're going to define each one of those two possibilities. Okay, let's move on and let's look at, okay, what about if the null is in reality false? Again, I'm making a condition. If the null is false, this time you fail to reject the null that is false. Okay, so again, like negative, though the person is diseased, so that's a false negative. So again, it's an error, and we're going to call this the type 2 error. And since we call this alpha, we're going to call this beta. Okay, and what is the value of beta? Well, it turns out that beta should not exceed 20%. So beta has to be less than or equal to 20%. And last but not least, the final square. This is where the null hypothesis is false and you rejected the null hypothesis. So it was a true positive. Okay, and so that's a correct decision, like this one. Okay, that's a correct decision. And it's 1 minus beta. But it has this very specific name, and that name is, we talk about power. And power here is statistical power. So if the maximum of type 2 error is 20%, means that power has to be greater than or equal to 80%. And these two together, they should add up to 100%. Okay? So these are the four possible scenarios that you can have, which resembles the true negative, false positive, false negative, true positive. And you think about it, true negative, it's a correct decision where you're declaring that the patient is free of the disease. And this is exactly the 1 minus alpha. So you are declaring that there's no difference, and that is a correct decision. Negative results, meaning that you're not finding any difference, you're not finding any departure from the state of nature, and this happens to be correct. False positive, that's where you're declaring that the results are positive, but you made a mistake. And that's exactly what type 1 error is. Type 1 error, you're coming and you're declaring that there is a departure from natural state, there is a difference between the two groups, whereas in reality, there's none. Okay? Then false negative, this is where you failed to detect the disease. And that's what type 2 error is. There is a difference between the two groups. There is a difference, there is a departure from the natural state, but you're failing to detect it. And therefore, it's a type 2 error. And finally, the probably the most exciting one of the four is power, and that's the true positive. You are detecting the disease. You are detecting a difference that truly exists, and that's the 80%. And this is power. And as I said, power is one of the most interesting things for researchers, and I'll explain that a little bit more in detail. But let me redo the table once more, just that we get a good understanding of what is happening. So just cleaning up real quick. Okay, so again, um, the idea is that you have reality that you don't know what reality is, otherwise you wouldn't be doing your research, okay? And your reality is one of two things, okay? Either your reality is that there's no difference, okay? يعني the null is true. Remember, the null always says something is equal to something, and therefore the no difference, okay? So people receiving the drug have the same blood pressure as people receiving the placebo. That's the null, okay? Meaning that, and if this is true, the drug is as good as the placebo, meaning the drug is not working. And that's part of definition of the null, right? The null is assumption of innocence. The drug is innocent of any effect. So either that is true, so that's the null is true, or there is a difference. So a difference does exist, okay? And therefore something is not equal something, and that means that the null is false, okay? But remember, we don't know reality. Therefore, our best attempt to figure out reality is doing a statistical test. And the statistical tests that we've been doing are the pair t-test, the independent t-test, the one sample z-test, etc. And here two things can happen. Either you're going to fail to reject, so you're going to fail to reject because your p-value came out to be big, so it's greater than or equal to alpha, that's or you're going to reject the null hypothesis, and where the p-value is less than alpha. All right? So again, the test can lead you to two places. All right. So, and we said that out of this, you can get four possible scenarios. Scenario number one, where there's no difference and you are failing to reject the null hypothesis. That is correct. And this should happen 1 minus alpha percent of the time, meaning that if your alpha is at 5%, this is going to be 95%. Now, what is this is actually, as I mentioned, this is a probability, and it's a conditional probability. What the condition? The condition is that the null is correct, the null is true, and it's the probability of failing to reject the null. So it's a conditional probability. All right, the second one below here you're rejecting the null, although the null is true, so you're making a mistake, and this is the alpha, and we call this the type 1 error. So this is type 1 error, and it should happen only alpha percent of the time. So if alpha is 5%, it should happen only 5%. And what is the definition? Well, it's also a conditional probability. What is the condition? Here's the condition right here. The null is true. However, you are rejecting the null, and therefore you're making a mistake. These two together should add up to 100%. Okay, so what does that mean? Well, this means that if you have a drug that has no impact whatsoever, okay, and if you were to fund 100 studies that will run exactly the same, according to this law right here, 95% of these studies are going to come back and they're going to tell you that there's no difference between the drug and the placebo, and they would be correct. However, 5 of these 100 studies are going to come back and they're going to tell you that there is a difference between the drug and the placebo, and they will be wrong. Okay? So that's what 5% error means. And it's 5% because you set alpha to be 5%. If you were to set alpha at 1%, then this will happen only one time, and these will happen 99% of the time. All right, let's move along to the other side here. What if the drug actually works, meaning the drug has an effect? Again, two possible scenarios. Either you're failing to reject the null, and that would be wrong, and this is type 2 error. This is type 2 error. And this should happen beta percent of the time. And we said beta has to be less than or equal to 20%. So 0.2. So what is this? It's it's a conditional probability. What is the condition? The condition is that the null is false. So condition that the null is false, this is the probability of failing to reject the false null hypothesis, and therefore it is an error. The last one is the probability. That's the probability. Again, it's a conditional probability. It's the same condition as here. So the null is false. However, you are able to reject the null, and that is what we call power, the statistical power. And this should happen 1 minus beta of the time, and hence it's greater than or equal to 80%. These two together should add up to 100%. So how does that translate practically? Practically, if you have a drug that actually is better than the placebo, and again, if you have money to fund 100 studies to run exactly the same way, if your power is at 80%, it means 80 of these 100 studies are going to come back with results indicating that the drug is actually better than the placebo. However, 20 of these 100 studies are going to come back with a declaration that the drug is not better than the placebo, therefore failing to detect the superiority of the drug. Okay? And therefore, basically, these are the 4 possible scenarios that can happen. Now, when we are doing a study, do we know where we are? The answer is no, we don't, because knowing where you are requires that you know reality. And if you knew reality, you wouldn't be running the study anyway. So why we talk about these things? We talk about these things because it's important to hypothetically, theoretically think about them and know what is happening. In reality, when you're running a study, you either know that you failed to reject or you know that you rejected. And therefore, once you fail to reject, you can hypothetically think that you either made a correct decision and therefore you are here, or you made an error, and that would be a type 2 error. Again, what is a type 2 error? Type 2 error is failing to reject a null hypothesis that is false, failing to detect a difference that truly exists. This is the false negative. Okay? So hypothetically, you're thinking to yourself, I'm either here or here. Or if you actually rejected the null hypothesis, then again, you can think about either you have made a mistake, and in that case, it would be a type 1 error, or you did not make a mistake, and therefore it would be the power. Now, if you made a mistake, that would be a type 1 error. شو معناتها type 1 error? Well, this is the false positive, meaning that you're declaring that there is a difference, whereas in reality, there's not a difference. Okay? So, what do you think is the most important thing for the researchers? If you think about a pharmaceutical company that has made a drug, okay, and this drug is supposed to, for example, lower blood pressure. Well, the pharmaceutical company has spent a lot of money making up this drug, and the drug went through basic tests at the lab level, and then they went into the animal model, etc. So the pharmaceutical company, by the time they've reached their study, they feel that their drug actually works. It's more than a feeling. It's a belief. They have a very strong belief that the drug works. Shumanita, the drug works. It means that the drug lowers blood pressure. And we know the null hypothesis declares innocence. So innocence means the drug doesn't do anything. The alternative hypothesis would be that the drug actually has an impact. Therefore, the pharmaceutical company has a very strong belief that actually the null is true and the alternative is the correct, the null is false, I mean, I'm sorry. And the alternative hypothesis is true. Therefore, they have a very strong belief that they are here. Okay? So once they are here, where you think they want to fall? They want to fall into the false negative or they want to fall into the true positive? Obviously, falling into the true positive, that would generate results indicating that the drug works, and therefore they will be able to release the drug into the market and start, saving life if they're thinking about saving lives, or making money if they're making about making money. So, having said that, what I'm trying to say is that um, when when a pharmaceutical company has made up a drug, they feel strongly that their drug is effective, meaning that the alternative hypothesis is the correct one, meaning that the null hypothesis is false, and therefore they would want to do all that they can so that they fall in this category right here, which is the power, meaning rejecting the null hypothesis. So, what can they do to impact the power of this study? And the answer to that is actually there are two things that impact the power of the study, and I'm going to discuss them in the following video.